Okay, I'm going to go ahead and start talking, and I'm going to turn it over to you in a minute, okay?
Sure, no problem.
Okay. All right. Hi, everyone. My name is Rob Canzaneri, and I would like to welcome everyone to the Data Architecture Virtual Chapter for PASS. And today we have Nigel. He's going to give a session on SQL tips and tricks. Nigel, I met him at PASS, and I really enjoyed one of his sessions, so I asked him to come to our session today and present. He has over 8 years of database experience and a decade of technical experience. He is the chapter leader for the SQL Server group in Trinidad, and he's also the chapter leader of the PASS Azure virtual chapter. We'll click on here. PASS has a number of great events, and here are some upcoming SQL Server and SQL Saturday, events in the future, and they're really great. If you'd like to attend them, you can go to their website and log in and register. PASS also has a volunteer program to recognize all the volunteers. So if you know someone that's doing volunteer work and you really like to nominate them, they have a website here that you can email PASS and provide some information, and they could be chosen as a volunteer, I believe, of the month. Okay, so with all that done, I'm going to turn it over to Sammy now. Nigel, and I'll let him start the presentation. And I want to thank everyone for attending. So here we go. Okay, Nigel, let's see if it's working.
Okay, are you seeing my screen?
I see it now.
Okay, so let me start it off. Hello everyone, welcome to today's session, T-SQL tips and tricks. Thank you, Rob, for introducing me and for organizing this event. So as Rob mentioned, I'm from Trinidad, and sometimes my accent can be a little difficult to understand. Also, I speak very fast sometimes, and especially when I'm talking about SQL, I kind of get all excited and talk really fast on some topics. So if you have any issues hearing me or seeing my screen, or you want me to slow down, please just send a question or a message, and Rob will tell me slow down so that you can catch up on what I'm saying.
Hey, Sammy, can you pull the mic away a little? Because it's just a little unclear.
Okay, hear me now? Better?
Say something else. Let's see.
Are you hearing me better now?
Oh, yes. It's a little better, yeah.
Great. All right, so I'm going to start off. Well, Rob just introduced me, but one thing I want to highlight from the slide is the fact that I am the virtual chapter leader for the Azure virtual chapter. And the good news is next year we plan to have lots of great events. So I look forward to most of you attending these events next year. Look out on PASS site to see when these events are happening. 2014 is coming out, so we have a lot of new stuff to show next year. So I like to start off my sessions kind of managing expectations. I know, you see T-SQL tips and tricks, and everyone is going to want to come. Just to let you all know, this is a level 100 session. Normally, a lot of people say that level 100 isn't really time or effort, but surprisingly enough, it's a set of information that people know already, but normally when you check, they actually don't use the information that they have. So what I'll encourage you to do is stick around. It'll probably be a good refresher, some things that you might have done and realize, oh, you could go fix this now, or who knows, you might actually learn something brand new in this session. So stick around for the next hour, and hopefully I'll be able to teach you at least one new thing. So the agenda for today is just a basic introduction for T-SQL. I'm going to talk about the logical query processing order, best practices, which really is not a documented thing, but really a best practices from my point of view, based on my experience as well as information that I've gotten from other presenters and MVPs. I also will talk about some big things that people normally use: select star, NOLOCK, order by, difference between union all and union, null, data types, and search arguments. So I'm going to start off with a basic introduction just to get you into it. So I lecture on database technologies, and as such, I have to teach SQL all the time. Not necessarily T-SQL, but SQL. And I like to start off by letting my students know about where SQL is from and the concept that drives T-SQL as well as other languages that is actually a dialect of SQL. So SQL is based on the relational model, and the relational model is a mathematical model whose core foundations are set theory and predicate logic. Normally when you say these kind of things and people hear maths, they get nervous, they get anxious, they don't want to do SQL anymore. But it's not difficult maths, it's basic maths, and then the logic behind it that you use, being a programmer, being in the IT world, makes it easier than it was in the days when you actually had to learn maths for the first time. Now, T-SQL, as I mentioned, is a dialect of SQL. It's actually Microsoft dialect. Different vendors will have their own versions of dialects of SQL. Microsoft version is T-SQL, and as such, it will have the features of SQL, which is the standard body SQL, but also has extensions for the standard SQL, which are some of the T-SQL features that you currently use in your work environment. As I get into it, I'll probably touch on standard and non-standard statements and give you some kind of insight on the difference probably between SQL and T-SQL. The other thing that you should know is that if you understand T-SQL in a relational way, it actually helps you to write better T-SQL code. This is something that Bengan actually tells everyone at the sessions or in his books, and I'll actually give you some resources that you can check out after the end of the session to kind of get you in the mindset of writing better T-SQL code. So I'm going to start off with logical query processing. So if you look at the slide, you see some SQL code, and what I want you to do is probably look at it and see if you see any errors in this code. Right? The thing is, with SQL statements, there are two issues that you could run into. One of them is syntax error, and the other one is the wrong result when you run the query. Now, some people have this concept, developers, admins have this concept that they need to understand the underlying table structure or the data that is stored in order to avoid both types of errors. But the truth is, syntax errors is actually quite easy to avoid without understanding the table definitions or even the data. So if you understand the logical processing order, right, then you'll be able to actually spot the error in this code. So your normal keyed in order for your query will select, from, where, group by, having, order by. But the actual logical order is from, where, group by, having, select, order by. And if you think about it, this is exactly how your mind works when you're looking for data. The thing is, if you're accustomed with your database and your tables, you automatically type select and you type out the columns that you want, and then you specify the table. But if you're brand new to a database, the first thing that you do is when you need to get the information, you have to find out which table you want the information from. Then what kind of predicates you want to show that you just return the rows needed, and then you deal with the group by, having, and then say what is the actual columns that you want. So based off of this, right, you should have been able to tell that the error was actually in the where clause, right? The issue being here that, if you notice, the select statement has C3 as name, right? I'm gonna just highlight here. I can't highlight it. Sorry about that. The select select C3 as name, right, is the alias specified in the select statement. But based on the order, you notice that the select is actually number 5, and the where happens at number 2. So at number 2 here, which is the where clause, this name actually means nothing to SQL Server. He doesn't understand what this alias name means because he's not finding name in the random table. So actually knowing the table and the data isn't necessary all the time, right? Simple things as knowing when to use aliases and how to actually when to specify it is important, right? So you notice the order by name is not an issue because based on the order by name, right, actually gets dealt with number 6, which is after the select. So the system already knows now C3 is name, right? Another 2 samples that I have, these with the fact that if you understand what actually happens in the phases, a basic understanding of what happens in the phases, you'll be able to actually spot some other syntax errors. If possible, you could probably take a look at it. I'll leave it up for a minute just for you to actually see if you spot any errors in the 2 samples highlighted here. Alright, so hopefully you've got time and you actually spotted the error. If not, I'm going to highlight it here now. So you notice the first one, total number multiplied by 12 is the issue. Reason being, right, the actual select statement part, aliases created by the select isn't visible to other expressions in the same select. So even though we sum V2 and named it total num still wasn't valid afterwards, so we couldn't actually multiply by 12. So that alias cal actually would show error because it doesn't know what total num is, right? So part of the process, right, for the select, right, what it does, it actually produces a result as if the select happened all at once. That's why total num, which is specified in the second column, cannot be used in the third one. The second sample, well, sample number 3, V3 is the issue. V3 is the issue because the group by clause groups data from the select table and produces a single summary row for each group. So you'll notice that the group by here is by V1, and then the select is V1 sum V2. Now, the select list must be a single value per group. Since you're grouping by V1, it means that you're selecting by V1 to be a single value. And the sum of V2 would actually return a single value for each group. However, V3, if there's a column name in your table, actually won't actually return a single value because it's not included in the group by, nor does it have an aggregate function. And understanding these phases, like select phase, group by phase, as well as the order, helps you to spot syntax errors early. I know a lot of people might think that what's the big deal, because if you actually use your DBMS, you'll see these errors because it will throw an error. And you should only focus on if you're returning wrong data. But the truth is that if you have big code samples to deal with, right? For example, if you have to write a lot of code for application, this will minimize your time and effort to find and fix issues if you understand this, because you'll be writing proper syntax initially and avoiding these kind of errors. Another thing is, if you're like a consultant and you have to deal with someone else's code, or you're just fixing another developer code, this understanding makes it easier to understand scripts that you're given. I also want to highlight the fact that ensures accuracy comes from the fact of, if you group by multiple fields, multiple columns, you could actually get the wrong result, but not know it's wrong because you didn't specify it in the select by. So the person getting the information will get the correct selected values, but if you add extra columns in the group by, you could actually be getting wrong data. And the understanding of performance issues, I'll touch on that a little later when I talk about the order by. But as I tell people, if you try to rely too much on DBMS to do some of the simple things that you could do, you'll be spending a lot of time wasting adjusting code. And also, when it's time for you to actually jump in and deal with an issue, you still have to depend on the DBMS. So knowing how to spot these errors, because you understand the logical processing order as well as what happens in the phases, is very useful. All right. So jump into my next session now, which is best practices. Am I going too fast, Rob? Or is it good?
This is fine. Thank you.
Okay, great. So as I mentioned, best practices is really something that isn't documented. Everyone has their own best practices, and as I mentioned, I lecture for SQL. So because I lecture SQL, not T-SQL generally, but because I lecture for SQL, I have to teach people who want to use different DBMS. They might want to use Oracle, they might want to use Microsoft Access or SQL Server, they might want to use MySQL. And the thing is, I can't cater for all the vendor features or functions all the time. So the best thing to do is actually teach you standard SQL and then let them use their vendor features or standards if necessary. So that being said, as a benefit, teaching the standard means that if the student wants or the person wants and they want to move from SQL Server to Oracle, right? They move their code won't break because using the standard means it's actually built in to all the vendors. So two examples right here. You notice the not equal to operator, which is the less than and greater than sign. Most people just know it as the exclamation equal sign, which isn't really the standard way. Another thing that people probably don't know is non-standard is convert. Cast is actually standard, so cast will be using different DBMS, whereas in some DBMS, convert might not work. So knowing the difference between standard and non-standard helps you in terms of moving from one platform to the other. And again, this is coding as well as math, so practice makes perfect. If you're custom writing not equal to as exclamation and equal sign, you automatically go onto the new platform and type not equal to the same way. So as I tell most people, if you know the standards, it's actually better for where there are standard features. Another thing that I think is very useful is aliases. If you notice, I have two sample code. The top one actually just specifies person dot and the actual column names, and the second one actually uses persons.statePreference as SP, which means that every time I'm referencing the table person.statePreference, I'm actually using SP to reference it. Now, to me, aliases make it easier to actually read code. This is a simple join with just 2 tables, but imagine you have a join with like 4 tables, and on top of that you have it inside a code. You have a script that has about 6 of this, and you have to go through this to find an issue or to verify that it's working properly. And actually dealing with something like this without aliases is very tedious. To me, having simple things like SPCR makes it easier to actually read through the code. Also, it's less code to deal with, as you can tell. So I find it very useful to specify aliases. Of course, especially if you're typing this up, and I mean, we have IntelliSense now, so actually typing this up wouldn't be an issue. But if you actually have to write code for exam, this is very useful. Aliases is something that I recommend to most people, especially when I have to go and deal with their system. The other thing that I wanted to highlight is there's 2 ways to actually do aliases, right? As you notice in the first slide, we specified as for the aliases, and I'm just going to jump back to the first slide just to show it. You'd see that there's as in the select part highlighted in blue as well as the from part. Now, if I had left out the as, what will happen is it will still show up as an alias. So where I have SP name as state provenance name, if I left out the as, state provenance name would still show up as the alias for SP name, right? So there's two ways to specify alias. One is by using as, and one is just by leaving a space between the two words. Now, I don't like the idea of leaving space to specify alias, because then you run into some code and you're wondering, is it really an alias or did they leave out a comma? So in this code here, you'll see a piece of code highlighted in green that has cr.countrycode space cr.country region name. And the question is, did they leave out a comma or is it supposed to be an alias? Now looking at it, you could tell that, you know what, every time we mention a field, a column from the table, we specify the table name in front of it. So cr.country code and then cr.country region code and then cr.country region name. Chances are this is actually supposed to be a column from the table. So chances are a column is missing. But suppose you had the code without you referencing the table name in front of it. At that point in time now, as you can see in the new slide, which one is accurate? Is it the as is supposed to be there or the comma? Is it supposed to be an alias or is it supposed to be a new column? And that's an issue that you have if it is you're not using as to specify your alias. So I recommend using as to specify your alias, so it's just easier to know if something is missing or not, as opposed to using space. Now, this is not a valid piece of code, so I can't run it to show you the result. But the truth is, if I run this code as is right now, country region code will be returned, and country region name will be returned as the heading for it. Actually, I believe I have it up, so I'll just show you. I'm going to jump across to Management Studio now. I hope hopefully you all have seen this. So if I plan not to type in my demos, but I'm going to do it. So and I'm going to say name. Let's see, country region code, and I'm going to say name. So if I run this, right, you get two fields, right, being returned, country region code and name. If I left out the bracket, right, looking at that, you could probably say that, okay, I'm specifying country region code as alias name. But the truth is, I left out a bracket, and when I run the results, I get back country region code data with the name being the heading of the result set. So to avoid something like this, I use as, so that way I let the person who's looking at the code know it is intentional that name is being specified as the alias for country region code. Okay.
Nigel?
Yeah.
We have a comment here from Mike, and he mentions that there's another way too where you can put an equal sign in there. He said that that'll work too for the as. I believe that's what he's saying here.
Okay. Well, like this?
Yeah, I think that's what he's saying.
What it does, it actually still pulls back country region code as the heading.
Oh, maybe he meant it the reverse way.
Right. So it pulls back the name as the country region code. So
I'm thinking he means if you say name equals country, yeah, you got it. Okay.
Right. So what he's saying is, if you use the equal sign, yes. But even self, the best thing to use is the as, so that you can verify that your purpose of this alias, your purpose is to actually specify an alias. So whether you use an equal sign, I'd probably still not want to use that, because I probably use equal sign other ways as well. The as I would suggest as the best practice, so that way whoever's reading your code know that your intention is to actually put out an alias. So this is the same code that I had up that I'm just going to run, and you'll notice two things happening. So the first one, right, it pulls back, there's no aliases, and you notice that the name here in the first one is the name of the country region, right? The second one now, using the alias, I could specify the name as country region name. The thing about aliases, as well as making sure it's easier to write code and read code, is that it actually helps you give more meaningful information in a result set. So, and it's also could be a good way for security as well. So rather than someone knows that I actually have a field called name or column called name in my table, using an alias, country region name, right, doesn't let them know the name of my columns, but also gives them more details about what data this is. Instead of name, and I'm assuming, okay, name is what? In the first one, name was the state provenance as well as the country region, and it wasn't very meaningful. But in the second one, state provenance name as well as country region name was more meaningful. So that's how I like to deal with aliases. The other thing that I like to talk about is database schema. Now, database schema, as I highlight, is a name container that is used to group various data objects like table views, etc. It's very, very useful when it comes to security and management. A lot of people, especially people coming from 2000, didn't really adopt it in 2005 and probably 2008. So a lot of their tables were still left as DBO, instead of specifying specific schemas for specific tables for management and security purposes. But, for security and management purposes. But the thing about schemas is that it is part of your naming convention. So generally in SQL, right, there are four parts to your naming convention. There's the server name, the database name, the schema name, and the table or the object name, So there's four parts: server, database, schema, and object. Now, most of the times when you're connected to the data source, you're already connected to the server, you're already connected to the database. So when you actually write code, you want to target the object. Most people like to target the object by just stating, select whatever from object name, and doesn't like to specify the actual schema. So I'm just going to jump back to Management Studio here. Close this off. Right. So I have two queries. One actually uses schema and one doesn't use schema. So the top one doesn't use a schema and the second one does. And I'm going to execute it. And what you'll notice is that if you look at the bottom here, I don't know, Rob, are you seeing this properly?
Yes, I see the row count, yes.
Okay, so if you look at the row count in the bottom here, right, you'll notice that for both of them is the exact same, right? But what I have up is the execution plan. And you'll see that the first one that doesn't use the schema name, right, actually does a table scan, and the second one does an index scan. So does that mean using schema improves performance? The answer is yes and no. The catch here is that if I hover over this, and I'm just gonna zoom in, right? If you notice if you notice in the object, you'd see AdventureWorks dbo.says_order_detail, right? If I hover over this one, you'd see AdventureWorks 2012.cs.salesorder.detail. What happened is I actually have two tables in this database. I'm just going to bring it up here. Right? I actually have a dbu.salesorder.detail, and I also have a sales.salesorder.detail. And when I ran the query, the first one that ran actually selected information from the dbu.salesorder.detail. And the second one pulled data from the sales.salesorder.detail. And because I didn't have an index on it to use for the DBU one is the reason why it took longer. The thing is, you actually have situations where sometimes somebody might come and have a database with multiple tables having the same exact name but different schemas, right? Or objects having the same name but different schemas. So you have to be careful for it. You might actually have a database that doesn't have that and write code for it, and then later on someone comes and they copy across a table just to do some testing, just to play around with something, just for some archiving purpose, and your code now, which is specifying just the object name, is referencing the dbu.object name, which might be an archive table, right? So for long term and to avoid future issues, right, it's actually better to specify what is your schema name as well as your object name. So it actually is a good practice to specify your schema name, as well as if you're doing queries from a different database, then you have to actually specify your schema name and then your object name. So I recommend that to most people because you never know when you might actually have to implement schemas for security or management. Okay, so that was the end of best practices. I have others, like for example, using semicolons at the end of queries, which, you know, a lot of people don't do because SQL doesn't care about it really, but soon I heard news that it would care about it. So get in the habit of ending your statement with a semicolon. Also, well, I'll leave it as that. I was going to talk about joins, but it's a touchy subject, so I'll leave that for another time. So let's start off with some scenarios. Everyone talks about select star. Why is select star bad? From my understanding, from reading and seeing in action, cost is a big factor of why it is bad. A lot of people don't see that way because their concept is that, well, I'm not seeing the cost anywhere. Truth is, no one is running your queries off of your servers all the time. You're pulling it from you have an application server running your queries or getting data from your database, and it's going to be going over the network, and you have a whole set of data going across. Now, I have met developers who said that, here what, it's actually better to actually do work with your application. So what they do is a select star and pull everything from their database, their table, bring it across, and then let the application deal with the data. Now, that might seem like you're actually doing less work on the database side, but there's a cost to it. Your network is now paying the fine as well as your database, because the truth is you actually might have an index that caters for particular selects of data, and when you do a select star, you don't get to use your index properly. So you work your database a little more, you work your network, as well as you work in the application. So you're paying an extra cost, even though you're thinking to yourself that your application does it faster, so it's better this way. Another thing is changes in the table definition, right, can result in application issues, especially, or even worse, it could actually be bringing back incorrect data. So small demo of this. I'm going to be switching in like this ever so often. So I have this two query here. One is a select star, one is actually pulling specific fields, same way clauses. When I run this, right, and take a look at the execution plan, and you'd see that that select star is doing an index scan, and it's just very costly in terms of compared to the other one which does an index, seek to pull back the information because product ID is an index there, right? My thing is, people don't look at these things. They just believe that if you look at the results, it came back really fast. But that's one select. And if your application is doing hundreds or thousands, right, all the time, it will have an impact on your system. This other one, which is talking about the change management, in terms of if you change your underlying table, you can mess up your application. This was a really cool demo that I saw Aaron Bertrand did, and I told him I'm going to use it for this session today. So what I'm going to do is I'm going to create a table, right? So I just created this table called name, and in it, this name table has a first name and other, and I'm going to insert my name, my first name Nigel, and then my other names, which is Peter and Sammy, right? And then I'm going to create a view on the table name, a select star view, right? So when I do this, and then I run the view, select star on that, from that view, I see the table, ID, first name, other name, Peter Sammy. Hopefully you all have seen it. Rob, you seen it?
Yeah, I see it, yes.
Okay. If anyone is having issues, I'm talking too fast, please let me know. So then I realized here what, maybe other people will have more than 2 names for the other. Maybe they have a middle name. So what I want to do is actually change other to last name and then add a middle name field. So what I'm going to do is just change that there, and I'm going to alter the table and add middle name, right? So if I do this now, so what I'm going to do is I'm actually going to select ID, first name, middle name, last name from my table directly, and I'm going to do a select star from the view, which was created from a select star from the table. So in essence, the select star of the view is supposed to really pull select star from the table. But if you run it, you notice I actually have first name, middle name, last name in my select from my table. But my view is still pulling other and doesn't have middle names or last name. Right? If I actually update my database and I put my middle name in middle names column and then change my last name to just have my last name alone, right? And I run back the same exact query again, what you see happening is that my middle name is now Peter, last name is now Sammy, and even though it actually was adjusted in the view, right, the view actually doesn't have Peter Sammy anymore, it still has other as the column for the view, right? So what is happening is that you use a select star and you pull the values from the table to create the view, and now that you have the view created and you change the table, the view is still using the aliases given to it when it was created. It's still using other. So something like this system procedure, right, will actually fix that. So now if I actually run back this view, you would see it has first name, last name, middle names. Notice, of course, I run this back again, both of them. In my table, I changed my last column to be last name, then added a column and selected it in a certain order. And because I'm selecting this as a select star from the view, it just has first name, last name, middle names. So it's fixed now, but it's still out of order. The thing is, why would you want to have to deal with all these issues after you make a change to your underlying table? Because you don't want to type out the field, the column names, or the table. And I'll also highlight something simple that he showed me. If you don't want to type it out, right, you can just drag it out and it will give you the list of columns. That's if you don't even want to use the autocorrect, the IntelliSense. You could actually just drag it out and get it. You could even drag out the name of the table if you want as well. So select star has its issues, which is why most people say maybe you shouldn't use it.
Whoa.
That's okay.
Hold on one second. I'll get that.
Okay. So he left. I don't know if anyone has any questions. So when he comes back, he'll probably highlight it. NOLOCK. So even I had used NOLOCK before and didn't understand what NOLOCK actually did in the long run. But people believe that using NOLOCK hints would actually deal with blocking issues and just return the results fast. But some people who actually use NOLOCK thinking that they return results fast without dealing with shared blocks, right, might not understand the whole concept of dirty reads or uncommitted reads. For those who do understand it, the fact is it's waiting to be updated and you are pulling back that information before it's actually written to your database. So it's a dirty read. NOLOCK actually gives you, in some situations, you actually get uncommitted reads based on how it is you wrote your query. So some people would have not catered for that when they use NOLOCK, but those who actually understand what's uncommitted reads and dirty reads and know that NOLOCK gives you that and willing to accept the fact that they have to deal with that, one thing that they might not know, which is actually most important, I think, to many people, is the fact that using NOLOCK actually gives you situations where you get double reading of rows happening, or even situations where you miss rows. So beside giving you uncommitted reads, which might be acceptable to you, I don't think most cases you would want to deal with a situation where you have rows that are double read or skipped, right? So understand that NOLOCK, using NOLOCK, gives you a high risk of dealing with data consistency issues. Avoid using NOLOCK if it is you're all about getting your data for some report or some billing. Avoid using NOLOCK. My advice to you is write better queries and don't use NOLOCK. However, there are cases where you might actually just want to get a fast snapshot or see what's happening on it, see that stuff is happening in a database. I might just want to use the NOLOCK. So it has its values. It's just, if you don't understand the drawbacks of using it, you'll be using it in a bad way. Other thing, order by. So I mentioned earlier in the logical processing session that I would talk about the performance issues that you could minimize if you understand what is happening in the actual when you're actually dealing with the sections in the logical processing order. So group order by, which is the sixth one that you have to deal with, if you have an understanding of what's happening in that phase, you realize that the fact is it is necessary when you want to get order to specify order by. Based on set theory, there's no order guaranteed in your tables, right? Granted, you think that when you run your query, you always get it back in a particular order, right? And that's because you have an index, so you believe that, okay, every time I run this query, I'll get it back in this order, so I don't need to specify order by. Truth is, that is not a fact. Something else can happen to the underlying schema, to the index, to the data, and one day you run that query without the order by, hoping that it comes back in the same exact order that it has come back for like 1,000,000 times, and it won't. So if it is the order of results is important for some next process, you should specify the order by, right? Now, understand the order by has a performance issue, not issue, sorry. It has a big performance cost to it, right? And knowing that means that, knowing the fact that order by is needed to guarantee order for your result set, as well as understanding that order by gives you a performance issue or impact, then you have to weigh out the both side of performance and guaranteeing order and decide whether or not this order by is necessary to use. So just want to highlight it here. In this piece of code, you notice I have same exact code. All I've done is just order by unit price on the second one, but it's the exact same code that's on top, first 3 lines. So when I execute this, result set was really fast, but if you take a look at the execution plan, you realize that this sort has a high cost. Right? Now I'm not going to go into too much details about explaining execution plans, but you can see the first one does an index seek, right? Because it's not dealing with any order in by, right? But if you look at the results, right, it comes back in whatever order they want to bring it back in. This one now, it comes back in an order based on unit price, which you cannot see, right? But there's a cost applied to it, right? At the end of the day, as with maths, there are many ways in which you could actually, and code in general, there are many ways in which you could write your code to get back the results that you want. So not all the time do you need to actually use order by for certain things. A good example is, and I've seen this happen a lot with students as well as professionals in the field, they get so accustomed to using features that are built into the SQL Server that they don't understand the impact it has beside performance in terms of accuracy. So if I ask them for the person with the highest score from a table, right, what they do is they order by score and then they pull back the top one. And for most cases that might be right, but of course there's a cost to it. So if it is, I actually run these 2 queries, right? So the second query, it does the exact same thing, but what it does what we call in relational algebra a division, where it checks a score to a particular score. If it's higher, it then checks it to the other scores. So it's a division that's happening here. So if I run these 2 queries, right, you see 2 different results. The first one, which is the order by score descending, and the top one pulls back the highest score, which is 30, which is correct. However, if you notice in the second one, which does it in a different way, it pulls back 2 values, both of them being 30. So while it is correct that the score is actually 30, the problem is because of the top one, it only pulls back 1 value, whereas the second one pulls back the 2 IDs that actually has the highest score. And in most cases, for those who watch soccer, right, or any games, right, when you have someone who has the highest number of goals or the highest point score, right, it would be really lame if you give one person that prize when it is 3 other people actually had the same exact value. So the second query actually gives you the proper results that you want. And if you look at the execution plan, you would see that using the order by actually is more effort in terms of the course, right? But of course, this is not always the case. It's always based on how much data you have and also what is being stored. So this query, which is these 2 queries, is the exact same process, which is the first one does an order by on top. The second one does a division to actually compare the values, right, for the modified date. And what it does, it actually pulls back the order on the last day, right? So if I execute this, you would see the first one pulls back 1 value because of the top one, and even if I specify top 5, it'll pull back 5, but it'll still be wrong because on the last day, which was 2008, July 2008, right? July 31st, 2008, you notice that I actually have 96, right, transactions happening on that day. So what you use order by for needs to be weighed properly for not only performance but accuracy as well. If you look at the execution plan, you would see that the second query in this case actually costs more, and the reason being is because of the data that is stored. So not all the time would it be a bad performance choice. Some cases it would be a good performance choice, but it still not be accurate if it is you're using it wrong. So understand the limitations of it, understand the effects of it, understand uh, the negatives and positives, and weigh it out before deciding to just stick in an order by. A lot of time you look at code and people are doing selects and they're sticking an order by, and you ask them, why are you sticking in an order by? Do you actually need it to return in this order? And they're like, no, but what's the harm in putting an order by? It actually looks better, or it looks neater. There's no harm until, you call me to then actually figure out what's the performance issue, and then I tell you that order by is the issue. So,
Nigel,
yeah.
we have a question here, and I thought I'd relate it back to you. I have a question about reporting purposes. Do you recommend doing an order by in an SSRS report or just a SQL query?
The order, it will be, this is where we use the most favorite statement of it depends. You could actually do an order by for the query and bring it back for the report, or if you want, based on the field that you're bringing back, you could actually do the order in the report itself. So like you could do filtering on the report, like how Excel is, where they have ascending and descending order. It all depends on the amount of data you're dealing with, as well as the type of report you have. My advice is try the order by, check the performance that it happens, because you have to, even though you run it one time, you have to consider that many people might be running these reports many times. So look at the performance, check out execution plan. If you're not familiar with execution plan, Grant Fitchie has a great book explaining about it. You can check it out. It's actually a free download on Redgate site for it. And decide if it is worth the cost there, or if it's actually better to put like a filter on the report in your report itself if you're using reporting services. The other option as well is, based on the data that's pulling back, you could actually let people export the data to Excel, right, and do their own sorting. I'm just showing out options here because I can't give you a direct answer to cover all reports. So you could toss around those different ideas and see if it's better. Which one is better? All right.
Thank you.
Okay, so I'm just going to run through this really fast because time is going and I have lots to cover apparently. So this is a sample code. I ask people lots of time, would this work? And the answer might be no. The truth is it will work. This order by 3 and 1 mean order by the third column and then the first column. It's not good practice to do that because you never know when someone might change around the order of the select. So it's not a good practice. The other one is a sample code showing a select statement and a table and then an order by row grid, which actually is the existing column but is not in the select. And I asked, can this work? The answer is yes. Even though you're not selecting the field, you can order by the field, right? And as I said, if you get a handle on what's happening in different phases, right, in logical processing order, you'll understand why this works. Moving on to union or versus union. It sounds like something very simple, but it isn't. A lot of people don't understand the fact that the concept of sets is a union brings back everything, right? And that concept is that, okay, if I use union, I'm going to bring back everything. The truth is, when you union two tables, you bring back everything, but you do not return duplicate rows. If you want all your data, duplicate or not, from both tables, right, or both relations, however you want to state it, you need to use your union all statement. Union will bring back everything, but not return duplicate rows. Union all will return everything as well as the duplicate rows. Again, as I said, it is a common mistake it's nothing if you have it right now. If you do have it, go fix it fast. If it is you actually want everything to get returned, especially for people who are doing reports. I see this happen all the time where they write their queries using union. The union has its limitations as well. Make sure you have the same number of columns on both relations that you're pulling back, otherwise it won't work. So all those things you just have to verify what is the limitations of both of them. But I just wanted to highlight the point: union all does not. Union does not return duplicate rows. Union all does. So make the changes that you need to for your queries. Data types. Now I noticed this chapter had a lot of data types topics in the past, so I'm not going to take too long on this, right? At the end of the day, isn't that right, Rob?
Yes.
Right. So I am sure they've said this multiple times. Data type is one of the most important decisions you make regarding your data. It might not seem like a big deal now because you're just going to fit in data so you can see your table get created, but then you leave it in production as is. It is very important. Some benefits: enforcement of data integrity, right? At the end of the day, you don't want people putting in a name where it should be a number. You don't want people putting in dates in different formats, right? Monday year, January 31st, 2013, 13th December 2014. You don't want to see those different things. So you want to make sure that you use data types to enforce that data integrity. Encapsulate behavior. At the end of the day, as I said, T-SQL is a dialect of SQL, and there's a set of features and functions that get created to expand on the standards. If you want to actually be able to use some of these features, functions, standard or non-standard, then specifying the correct data type allows that. You can't do a date add on a date that is actually a varchar. So I've seen tables where people actually store their data as varchar for whatever reason it might be, but then you lose all the ability to do different functions and capabilities that you would have if it was actually a date data type. Data size now might not seem as a big deal because at the end of the day, storage is cheap now. So what if I use wrong data size and I'm storing a lot of data and I have a little bit of data but it's taking up a lot of space? It is an issue, right? It happens to be a very annoying fact to deal with when you're actually doing maintenance as well as performance tuning. So if you're not familiar with data types or you don't understand half the things that I'm seeing right now, because I'm just touching on it real basic, I'd recommend reading up. I actually have a blog post on it. I think it still has lots of blog posts on it. Lots of the MVPs talk about it. Louis Davison, I believe Davison is his last name, or Davis, could be saying it wrong, talks about this all the time. He recently did one for the data architect group. So I'm sure you have that someplace, right, Rob?
We have a link on our site to the presentation,
right?
So they can watch it.
I recommend checking out. So I'm just going to touch on something really cool that I found out about a while back: data type precedence. So quickly to my management studio. If I run this query, right, what will be the result? 11, because it's a string. So 1 plus 1 string-wise is 11. If I run this query, what will be the result? Of the bat you're seeing, it's int, so the result should be 2. If I run this query, which is a string as well as an int, then what will be the result? Will it be an error? Will it be 11 or will it be 2? I give you 1 minute to think of it, and then I run it. And it's a 2. Why is it a 2? Anybody knows? I know. Rob, do you know?
I think it converted the string to an integer on the fly.
Right. So as it is, when different data types are involved in operands, SQL Server will convert the lower data type precedence to the higher one, right? In this case, int precedes varchar. So as such, it took the string and converted it to int. Of course, you, right, could always, if it is you wanted it to be a varchar, you could have specified that. But if you leave SQL Server to the side, SQL Server actually has a precedent chart which says which one is higher than which, and will convert it based on operands of different data types. There's actually a link that I could probably share later on that specifies the data precedence order. So in this case, int preceded varchar, so when we ran that query just now, that query returned 2. Alright, so 2 more and then I'm done, right? Nulls. Okay, so null is a big deal. I can talk about nulls for like hours, but I'm not. I'm going to talk about it very fast, and you need to understand that it is very simple to actually include a null in your table because all you have to do is specify null and allow that to happen. But dealing with null is very, very, very tricky if you don't understand the impact that it has on your queries. Null is a missing value and is not empty or 0, right? That is one thing you should note. Compare nulls will result with something, result with unknown. So if you ever read on nulls, you always see something called the tree value logic, which is dealing with predicates. You'd always get a value of true, false, and because of nulls, you get what we call unknown, right? So when you're writing T-SQL, you should consider nulls to avoid returning incorrect data, right, or information. Even if your database does not allow null, it's just best practice to just get in the habit of dealing with nulls. So quickly, I'm going to run through this. I created a table, had some data in it, right? So if I run this query, so I have a table called null tester. I'm going to pull back an ID, name, and total, where name, and I'm using not equal to Fred. So if I run this, I get 3 values, Jill, Harry, Jill, right? So therefore Fred is missing, so chances are I have 4 columns, right? I'm going to run my second one now, which all it does is does a group by ID and account for the number of records. If I run this, I see I have 4 records. So just to give it some more clarity, I'm running it back to 2 of them together. You notice in the first query where there's not Fred, I have ID 2 and 3 only, even though 2 is repeated. In the second one where I'm grouping by ID and I'm counting the name as number of records, I actually have 4 IDs. So is it that ID 1 and 4 name is Fred? So that's why it wasn't returned in the first query. If you count the number of records, you see we have 2, 2, 1, which means we're supposed to have 5 number of records. So let's check out the table and see what's actually stored in the table. And when we look at it, we actually have 7 records, right? But based on the queries before, it seemed as though we had 5 based on the count that we did, and based on the fact that when I returned not Fred, I got 2 and 3, it meant that 1 and 4 was supposed to be Fred. But if you look at it, Fred is actually 1, and 4 is null. The issue is, when it is you do something like not equal to Fred, you didn't cater for nulls, right? So it didn't return any null value. So if I run over the query now and I cater for null by saying name is null, what you get happening is you get Jill, Harry, and Jill, but you also get the 2 null values, which is 3 and 4. The second one, if I run it over, when I ran it, I got 5 records, but when you open the table, you saw 7 records. So 2 is missing. If I run over this query and I'm adding, so the initial query had count name. You can see it up here, count name. The second one, I'm actually using count name and count star. And I run it. And you see the count name one actually brings back 2, 2, 1, which was the 5 that we got. And if I use count star, I get 2, 2, 2, 1, which gives me the 7 records total. So nulls, if not considered and not considered in terms of the impact it have in terms of your writing a query, you could actually be pulling back wrong information. This first number of records would have said that I actually have a total of 5 records. When the truth is, I actually have a total of 7 records because this count name did not cater for the null. The last thing that I'll show you in null is that null does not compare to null. So if I run this query here, you should be hopefully familiar with sub-queries. If I run this query, you see 4 values: null, Fred, Harry, Jill. And what I'm going to do is run a query to compare to that. So if it's Fred, bring back the value. If it has a Fred, bring back the value. If it has Harry, bring back the value. If it has Jill, bring back the value. But as I mentioned in my slide, null does not compare to null. So a null value should not see another null value and bring back a result. So when I run this now, you see no null shown up here. And the reason, as I said, is because null does not compare with null. If you don't understand some of these null concepts and your database has nulls, you're running queries. As soon as you see results, you believe your query works. Chances are you have inaccurate data because you're not catering for nulls. All right, last slide, right? Searchable arguments, right? This is probably one of the most unknown thing that is probably the most useful thing to know when dealing with querying, right? What is the point of an index if you don't use the index, right? And say that this requires, right, so just because you specify in your where clause, right, the predicate as a predicate that deals with the index doesn't mean you're using it. Take, for example, this last demonstration that I have here. I have a table, right? Let me see, make it a little bigger. Right. So I have my table, DBO sales order detail, right? And I'm going to use date difference for the modified date, which is a field in the table, and pull back 3 values. I'm doing the same exact query, right? But instead of actually using the function on my field, I'm using the function on the date and comparing it to my field. So when I run this query, right, including the execution plan, it pulled back results. It came back really fast. That's great. Let's look at the execution plan now. The first one, right, actually does a table scan. Now, modified date is actually my SQL DBO. So I'm just highlighting my table here. I actually have an index, right, that is on the modified date. But when so in my head, I have an index on the modified date. So anytime I use modified date, it should be using the index. But if you notice, the first query actually does a table scan. It doesn't use the index. The second query now actually uses the index, right? And pulls back the information as well. And if you look at the result set, it'll be the same exact information. The reason being, right, is that the modified date has the index. When you use a function on the modified date, right, it is no longer using the column modified date. If I ran this in a select statement, they would ask me for an alias to specify it. If I use the modified date, it will come back as modified date. It is not the column. What it is doing, right, you're using a function on the column, so it's no longer going to be using the index, right? A quick example again, I have this person.person, and what happened is there's an index on the last name. I'm going to run the 2 of them and see if you could guess which one is the search argument one and which one is not the search argument one. So it comes back really fast, and when I go to the execution plan, right, you notice the first one actually uses index seek, right? And the second one does a scan. The thing is, when you specify last name here and have no function around it, it uses the index. Whereas the second one has a function on it called left, so it doesn't use the index. So understanding search arguments, right, helps you a lot in terms of writing proper code that uses indexes. So a lot of people create index on the tables and believe that they wrote code to use the index. And the truth is, all they're really doing is running a standard query that might do an index scan or table scan, right? So as it is, that is my last point or tips or tricks on.
Okay.
You okay?
Yeah, my phone's
Right.
ringing, and I'm trying to make it go silent. I don't know how. Let's see if I hit mute. It'll work. Sorry about that. Okay.
So this is my last slide on searchable argument. Tips and tricks. Just wanted to highlight before I go really fast some resources. Ben-Gan has a number of books as well as courses that's very useful. If he's presenting at PASS or anywhere, and you could actually attend, I suggest attending. Ian Bertrand as well has great T-SQL presentations, best practices, bad habits to kick. If you check out his blog post, Bad Habits to Kick, he highlights some of the things that you should and shouldn't do. And books on relational algebra as well as relational theory, right, is very useful because, as I said, T-SQL is based off of SQL. Understanding SQL gives you a great advantage. And of course, MSDN has great resources. So you can take down my contact information, send me an email, tweet me, check out my blog, which I hardly blog on these days due to conferences as well as presentations, but I'm starting back soon enough. Feel free to drop me an email if you have any questions. Send me any feedback on this session as well so I know if I need to add anything or make anything a little clearer. If you have any questions, I know we're kind of out of time. Even if we can't answer now, I could always send you a response if you email me. All right, Rob?
Okay. I really want to thank everyone for attending, and I want to thank Nigel for giving this presentation. And I'm going to go ahead and archive the presentation on the PASS website under data architecture, so everyone will have an opportunity to review it. And I'm going to and if you have other questions, you can send it to me, and I'll forward it off to Nigel. And I'm going to stop the recording right now.